Welcome back. I like to make it very quick. So since I've already presented the idea in a previous video, I'm just going to work at least one or two different variants for the remaining compounds that I had in mind. So with that, let's get started. Here's a compound as with the previous video. Let's have a quick quiz. Is the compound given an alkane, alkene, or alkyne? Assuming you got it right, and I'm guessing you are. It is a alkene because it perfectly fits the alkene's generic formulae of CnH2n. Does this compound contain 0, 1, 2, or 3 double bonds? Alkenes are just this, so it only contains one double bond. Well, keep in mind, one is always default, right? All compounds contain a single bond. All right, with that said, let's go ahead and draw the generic one, which is the basic straight chain version. Now, again, as I said, it is not possible for me to draw every single one of them. And I think I got 3, 3, 6, 7. Very good. So this is one. I'm going to draw a bunch here so I can work each one of those out. So CH3, CH2, C double bond C, CH3. That's 4, 5, 6, 7. And then let's draw one more. CH3, CH2, C, CH3. You kind of guessed where I'm going with all this, right? Not that hard. So it's already 3, 5 carbons. So I'm going to put my double bond here, which means I had met my 7. So it'll be this. I think I got it right. Very good. Okay, so let's draw the line structures for these 3 variants. How do we do that? As I said, find the longest chain. Usually the basic version does not have any substituent, so all 7 are in one straight line. Now, straight line is not necessarily an important word. As I said, the long chain is important. Some people say straight long chain all the time, and which means students are always looking only for a straight. Sometimes I purposefully bend it, so what now, right? So we have 7 dots, so we'll start from here. 1, 2, 3, 4, 5, 6, 7. Now, it's obvious, again, like I said, in this case, naming is not something we're dedicating a separate topic on it, but typically you would start numbering from a side that's more where the double bond is more closer to one side or the other. I'm trying to come up with words to say it. Let me try to paraphrase it. You start numbering from a side that contains less number of carbons with respect to the double bond. Okay, there's more than one way to say it. With respect to the double bond, on this side, there's 2 carbons. On this side, there's about 5. So we start numbering from here. So 1, 2, 3. Again, this is just a lead up to what is to come in the future, but I guess I don't want to just say something for the sake of saying this will be useful, which is why I'm saying it. So this is my first, this is my second, so it's between 2 and 3. Now, do you see why that numbering is important? I guess you can do it without that, but it's kind of helpful. So that's it. I've already explained the Ben means 2 hydrogens, okay? Now, you can, if you want, if I might ask you to just show the hydrogens for maybe 1, all right? So let's do it for this one. Again, our longest chain is, in this case, 6 carbons. So 1, 2, 3, 4, 5, and 6. And then, well, in this case, it's a strange thing, right? I mean, it's right in the middle. The double bond is here. So it's not on this side, so it's on this side. So which side should we start from? Well, this side has 2 with respect to the double bond, or 3. This side also has 3, but then this side has a substituent as well, right? But so if you have to decide which side you're going to start, well, this side also has 3 carbons, this side also has 3 carbons. Now you go for which side has least number of hydrogens. Well, this side has least number of hydrogens, right? So with respect to the double bond, so you go for that. So 1, 2, 3, 4, 5, and 6. So that means the double bond would be 1, 2, 3, and then whether you put it up or down, it doesn't matter, right? Now again, we will come back to the idea of numbering. It's not just enough example to drive the whole idea, but you know, I just want you to be aware of it. Okay. So let's go to this one. This is pretty obvious. So we'll start numbering from here because it's clearly very, very obvious, right? So 5. Again, we have 5 is the longest chain possible. I guess whichever way you drive. Well, okay, this is important. Now, the longest, with respect to double and triple, I think I did mention that when we did earlier, the longest chain, whatever you chose to be the longest chain, must contain the double and the triple bond. Oops, sorry. Must contain double and triple bond. Just because you have 7 carbon long chain, but it's all single, but the double bond is sticking out, that's not going to work. So you have to accommodate the double bond in the longest chain. So that's 5. So it's 1, 2, 3, 4, and 5. Double bonds here, and then this both are on the same. Now it's only one sticking out each side, so that's, again, put dot and connect the dot. Simple as that. Right? All right, why don't you practice line structure for C8, H18, at least 3 structure, C8, H16, at least 4 structures. Okay? Draw at least 4 line structures for C8, H16. Let's move on, and as with the quiz, I'm not going to even waste any time. It's an alkyne, and it's got 2 double bonds. One is default, so that means you only have 2 double bonds in an alkyne. As with the others, I'm not going to even bother with the straight one because, you know, let's start with the variant. So CH2, C triple bond C. I'm just going to start with this as my variant. So this is 5 and 6 and 7. And that's 1. And then I guess I can go using that as my basis. I can go this way. This means I've already done 6. So this just would be 7th. Again, CH3, CH2. Or I guess I could go this way. C triple bond C, CH3. How many do we have now? Let's keep a count on it. 4, 2, 6. Okay, so that will be, this is a different version. That's not the same thing as anything we've had. This is completely different. Okay. Well, that's good. All right, so let's draw. We have 5 and the 6 in the longest chain. So 1, 2, 3, 4, 5, and 6. And then the triple bond is 1, 2, 3 over here somewhere. So you say it this way, and then it sticks out of this above or bottom. It doesn't matter. I'm just basically drawing, you know. So again, 1, 2, 3, 4, 5. Longest chain must contain the double or the triple bond. So be careful of that. I will trick you. Now that I've said it, I will trick you. 1, 2, 3, 4, 5. It's over here somewhere, right? And then you have 1 above. Again, whether above, below, in this case, we're not going to worry about it. We will come back to it at a later point of time. If you want to keep them up, that's fine. Again, 1, 2, 3, 4, 5. Excuse me. 1, 2, 3, 4, and 5. It's between the second, it's over here. 1 above and 1 above. So That's all there is to a line structure. And I want you to give C8H14, draw at least 4 structures. What I mean by is line structures. Well, that's all I had to say on the topic of line structures. Things will become more complicated as we start to include other elements besides carbon and hydrogens, but for now, life is good, so stay tuned.